This is our DCSC project, PEAKVIEW, Business Management Data Platform, and our team consists of two people, Sanath, myself, and Arnav. So our project goals is to develop a full-stack business management platform with all necessary microservices, sales management microservices, which record and manage sales transactions, inventory management, it tracks inventory levels and costs, analytics dashboard, provide insights on revenue, expense, and profits, and authentication microservice. So we implement a secure authentication microservice using JWT and passport for all microservices. So our front-end features consist of inventory management dashboard, product listings with the stock levels, low stock alerts and restocking notifications, expense tracking for the products, and sales management dashboard, real-time sales tracking, customer details, sales order management with payment processing, auto-generated invoice with email or download options, and analytic dashboard consists of revenue, expense, and profit tracking over time. Graphs or charts like sales trend, profit margin, revenue by category. So the software and hardware components we used. So hardware-wise, we used Apple Silicon MacBook Pro for development testing environment, and softwares for backend we used Next.js, front-end React.js, and deployment Kubernetes for container orchestration, Docker for containerization, Google Cloud for production deployment and storage. Architecture, we use REST API for managing requests, and microservice architecture, authentication and all related management systems. And for authentication, we use JWT and Passport for secure user access. Database, we use MongoDB for all microservices. Version control, GitHub for collaborative development and version tracking. Debug approach. So we use console and log monitoring. We use the logging the React and Next.js to capture critical events, errors, and performance data. Cloud logging and error tracking. So Google Cloud logging tools and Sentry for real-time monitor after deployment. API testing. We use the Postman to validate API response and authentication workflows. Local and staging environments. Test in Dockerized local environments before pushing to staging to isolate and resolve the issues. And testing approach. End-to-end testing. Simulated complete user workflows and ensure the application functionality for the all backend APIs.
I'm Arnav. So now I will be going over the architecture of our application. As you can see, there are 4 microservices. There are sales, auth, inventory, and analytics microservice. The auth microservice is what handles the authentication, user registration, user login as well, and it is what creates the JWT token using a passport strategy in Nest.js. So for each route in every other microservice, like there are several routes in sales, in inventory, and in analytics. So we use a JWT card. It's a feature of Nest.js to authenticate the user that is accessing this route. So it is a very advanced version and production level handling of all these routes. So as you can see, we will define the API functionality, write the API logic, test using Postman, create the Docker image, push to GCP, GCP infrastructure where we configure the permissions, the IAM permissions, environment variables, and also secrets in Kubernetes secrets, and then we upload it to GCP. And then deploy the Docker image, setup, API gateway and load balancing where we have an ingress to access all of the backend, and then security authentication, and then testing and optimization. So if you go here, the authentication microservice, which I have already explained to you, it handles all these things. And the database is done using MongoDB Atlas. It is a cloud service that is MongoDB's own cloud. We use that as a service for our database. And then inter-microservice communication, we use the Nest.js's native TCP native transport layer protocol in order to, for example, if the sales microservice needs to validate a route, a user who's accessing a route in it, it needs to access and it needs to communicate with the auth microservice in order to authenticate the user. So that's an example of inter-microservice communication that we implemented. So I will be going over each of the cloud technologies that we use. So databases, we used MongoDB Atlas. I will show you the database. So as you can see, this is the database, and these are all the microservice databases like inventory, sales, user profile, and user documents like that. And REST API, we used REST API for everything, for all the routes. So as you can see here, the auth controller, here you can see the post login route, and if I go into sales and if I go into controller, so in SJS all the routes are organized into a controller file, so that's why it's all in a controller. So as you can see, the sales controller and the post route, get route, and there are a lot of routes like that. So that's the REST API. And then the virtual machines, we used Docker and Kubernetes. So we first use Docker Compose in order to locally test our development environment as we keep adding features, and then finally we use a cloud build with a CI/CD pipeline. We use a CI/CD pipeline that automatically detects pushes to our Git repository and contacts the Google Artifact Registry, Google Cloud Artifact Registry, and pushes the Docker image to that. So automatically when I press git push, it pushes the Docker image to that, and it is automatically deployed on Google Cloud using the Google Kubernetes engine GKE. So as you can see, we are using Docker and also Kubernetes. I will show you this right now. So you can see here our cloud build file. This is a cloud build file which handles the CI/CD pipeline. So we implemented a CI/CD pipeline for faster production deployment and testing. And if I come here, you can see our artifact registry, which is all of our images, right? It's all of our images that are being pushed. And if I come here, this is the cloud build, which is it shows a list of builds and pushes that we did. Using a CI/CD pipeline, and this is our ingress. The ingress is what we use, the entry point and the front, to access our whole application. So as you can see, we did the storage service using the Google Cloud Artifact Registry to store the Docker images, and message marshalling, which I already talked about. It involves the Nest.js TCP transport mechanism for inter-microservice communication. And finally, as I told you, we are using the microservice-based architecture with 4 different microservices, or sales, inventory, and analytics dashboard, in order to have a separation of concerns and separate each functionality and allow proper development. And finally, CI/CD pipeline, which I talked about, we using cloud build. Okay, so now I will be going over the load testing of the application, the amount of load it can handle. So as you can see, I use the WRK package in order to conduct load testing on this endpoint. This is our ingress endpoint, and this is the auth login route. And as you can see, the application was able to handle over 80,000 requests in a single minute, and the request per second was over 1,300 requests. So it is a very highly production level application, able to handle production levels of loads.
And this is our front end website. So this is the software which our clients are going to use. Our clients are nothing but the shopkeepers or vendors who want to track their sales. And this is our login page. And let me show you. Yeah, see, after the sign in, we have here 4 microservices, which is inventory, sales, analytics, and account. And first one is our inventory microservice. So here, user can add the products in his business. So he can add the amount of stock he has, and he can put a threshold value. So whenever the stock goes below the threshold value, so we'll send him a mail that the stock is ready, so he can go and buy the required amount of the stock. And we added a search option here to make the vendor to easily search the products here. So let me show you. So here, yeah, if vendor wants to search for the Apple products, so he can just type the Apple and see the only the Apple products which are being shown here. And if the vendor wants to add the products, he can just click on the add products and give some product name and give the stock value and give the threshold limit and the price of that particular product, and he can save it. So it will add the product into the inventory list. So we can just test it now. So we can test it on the search. See, now we can see the test product on the inventory one. And next we goes to the sales one. So here user going to track the sales of his products. So whenever any user wants to bought anything, so he can just record a take sales one. So he can just type the customer name and he can just select the product from the list. So here if user wants to buy the Apple iPhone, so he can just select the Apple iPhone and he can just select the number of quantity he wants to take. And then if we click on the save, yeah, so now my sales record is saved successfully. And when the user sell anything, it will automatically detect those quantity from the inventory. So we can see here. So currently before the Apple iPhone 14 Pro stock value is 148. Now it reduced to 146 because our client sold 2 of the products. And after the completion of the sales orders, he can just search the sales orders, like to which customers he sold the orders, and he can just click on the show order, which will show what and all the orders he has sold to that particular customer. And if you want to give him an invoice, he can just click on the generate invoice, and it will download a PDF file, so which will generate him an invoice file. So here we'll show all the details of the products which were sold by the seller. And here is our analytics dashboard, and you can see the first graph related to sales volume by the product. So here the customer can come and check which product has a more number of stock value among all of his products, and he can figure out like whether why this product is not going to sell out, so he can reduce the number of products he wants to buy. And next one, we are showing about the profit by product. So for each product we are showing the profit graph, so which product has the highest profit graph, so he can just compare the profit value, and he can increase the number of those kind of products which he wants to buy more, so which will give him the more profit. And final one is our stock value and the threshold value. So for each product we are showing the stock value versus threshold value. So if there is more number of stock and it's not going reduced to threshold value, so it will make sure that that our client has to change some changes in his business, and he has to change the products which he wants to buy. And our last microservice is our account page, and here we'll show all the details related to our client. So and here we gave the option to sign out. So when user is done, like if he wants to sign out from our website, so he can just click on sign out, and it will take him to the login page.